Hey there, Mrs. Banky here. I am creating a video to show you how to recognize and draw structural formulas, condensed formulas, and line structures for both alkanes and alkenes. And I've got quite a setup here actually. I have the image on my iPad, which you can kind of see it like this. And you can see that I'm on a nice sandy beach in the summertime, somewhere tropical, of course. And what's really cool is this little window here. I can fit in just about any of these boxes, should I choose. But what we have here is a chart with alkanes on it. And in this column, we have the structural formula. In this column, a condensed formula. And in this column, a line structure. Now, in each of the boxes, I did write the names of these things, and you may or may not have already been introduced to naming, and if you have, then this will look familiar to you. If you haven't, then it's something to look forward to. So in this box, this structural formula here, what you have to do is you have to draw a condensed formula and then draw a line structure for it. So for this one, excuse me, I will go ahead and draw the line structure. Now I will have to putting my head down now so that I can draw on my iPad. So I'm looking at pentane, and I'm going to draw in red. So as I'm drawing the condensed structure, the first thing I'm going to do is I'm going to draw what's at the very end, which is a CH3. There are the three hydrogens here attached to that carbon. So I draw CH3, and then I can put a dash in CH2, 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 and then another CH3 for the end. And this is what the condensed structural formula looks like for that. And I'm going to see if I can shrink that back down. It looks like it's keeping the text on there to be about the same size as it was, or exactly the same size as it was. So then we have to draw a line formula. So I'll use the middle one as an example. And this is called 4-ethyl 2-methylhexane. And let's just break that down a little bit. So we have hexane because there are 6 carbons in one straight line. 1, 2, 3, 4. I'll start over. 1, 2, 3, 4, 5, 6. And we start counting on the end that has the closest branch to it, which is this end right here. So this is my number 1 carbon. This is my number 2 carbon. This is 3. This is 4. We have 5, and then we have 6. So the root of this, or the end of this name, is hexane because it's 6 carbons in a row. So on my number 2 carbon, I have a branch which has 1 carbon, and that is a methyl group. And on my 4th carbon, I have a branch, and it has 2 carbons, which makes that an ethyl group. So when we're naming, we have to start with the branches first, and we have to do it alphabetically rather than numerically. So ethyl starts with an E. We start with ethyl, and then we have methyl. So we have to attach the number that the ethyl is associated with it, and since it's associated with the number 4 carbon, we use the number 4. So 4-ethyl 2-methyl hexane. So we have the methyl group on the second. So either way, here I will go ahead and draw the line structure. So the best way to do this is in a ziggity-zaggity way. And for every carbon, this end carbon is your number 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So it's not very neat. I think on your papers you'll be able to do it neater. Now on the second carbon end, there's a methyl group, and a methyl group is just a single line. And an ethyl group has 2 carbons. So 2 carbons has a zig and a zag. So we have 2 lines, 1, 2. So the line structure looks like that. Now, most of the time we will always draw our branches coming out of the V, and then in the direction, like if the V is an arrow, then we'll draw the branches coming toward the way that the arrow is pointing. So this is a line structure, and then the condensed. It cleared now. That's okay. It's on video. If you need to go back, you can look. All right. So here we have 4-ethyl 3,5-dimethyl octane. So this group, we have 2 methyl groups here, which is why that's a dimethyl. Now, when you draw the condensed structure in this one and the structural formula in this one, it's going to be the same substance. So for every single one of these, it's going to have the same name. The structural formula includes all of the hydrogens attached to the carbons. So let me go through a couple of examples with the alkenes. I am not sure what's happening right now. Okay. So we'll go through a couple of examples with the alkenes. I did not write the names on these, but I will go ahead and write that now. So this one right here is an alkene because there's a double bond. And the double bond, we have to start counting from the end that is closest to the double bond. So before we had to start counting from the end that had the closest branch, which would have made this one right here, the number 1 carbon. But in this case, the double bond, which is right here, is closer to this end, which is where we will start counting from. So since the double bond is connecting the second and the third carbons, and there are 1, 2, 3, 4, 5 carbons, the name of this would be 2-pentene. And we need to indicate that there's a branch here attached to it that is a methyl group, and that methyl group is on the 1, 2, 3, the 4th carbon. So this is a 4-methyl 2-pentene. And again, that 2 in the name is because the double bond is between the number 2 and the number 3. If the double bond were here, it would be, instead of there, it would be 1-pentene. All right, so I'm going to clear that because it's looking kind of messy. So let's draw the condensed structural formula for this. So one thing that we have to indicate here, I missed it. We can see here that these hydrogens are on the same side of the double bond, and that's an example of cis geometric isomerism. So the actual name of this would be cis 4-methyl 2-pentene. And a condensed formula really cannot indicate the cis or trans, which is, I'll show you that in just a second. So it doesn't really indicate that. So I just kind of follow the same way I did before. I have a CH3 dash, and then I have a CH connected by the double bond, CH dash. On this carbon, I have a C and an H, but coming up off of it, there is a methyl group, which is a CH3, and then I have a CH3 there. Now I'm going to go ahead and draw the line structure for this one right away. So I do know that this is a cis, and whenever we have a cis geometric isomer arrangement, the actual structure, if we were to build the molecule, would look like this. So that would be a single bond, and then the double bond would right here. So it kind of takes on a C if I were to turn this on the side. Now each of those are hydrogens. So when I draw this, the line structure, and I would do this in the other spot, not right here. I have my first carbon, my second carbon. Between my second and third carbon, I have a double bond, and then this is my fourth carbon, and then I have a fifth carbon. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now on the fourth carbon, I have a methyl group. So the line structure would look like that. So these aren't quite as easy as the alkanes, but the more you do it, the more that you'll get the hang of it. So you can see one of the things that I did here. I have to activate my pen again. I was pretty on this one. You can see that this is going to be a cis structure because it's like that. Now a trans structure of the same thing would have 1, 2, 3, 4 carbons, and it would look like this. So if we built it, the hydrogens would be on the opposite side of the double bond versus this one. The hydrogens are on the same side of the double bond. So down in this bottom corner down here, that is a trans arrangement. So I'd like you to go ahead and give these a try, and I would like you to take a picture and post your answers. And when I see you next, or if it's over the weekend, I will share my answers a little bit later so you can make comparisons. So good luck. I hope that you enjoy drawing condensed structures and structural formulas and line structures. One of the most difficult things actually is drawing the structural formulas, because it's often difficult to try and get all of those hydrogens in that tiny little space. So you have to write really small. If you don't want to write really small, you can use another sheet of paper and connect it and write it bigger if you want to. So thanks for watching. Bye.